From the examples to understand science behind the prediction, some of the terms used in this chapter, calculating the chances of the happening of an event. Suppose you and your friend is going to play a game Ludo. So who wants to play first? Then it decides by tossing a coin. Okay, if who got head if they will start or maybe tail. There are two outcomes will decide who is going to start the game Ludo. Then this is called experiment or a trial. In this action, we will get head or tail. These two are called outcomes. The result is either head or tail. If you write these head and tail in a set brackets, then it is called sample spaces of the event. Okay, now heads is counted as H and tails is T. The set of all the possible outcomes of an experiment is called sample spaces. Then how many sample spaces are there? Okay, are you played with this, children? What is this? Die. A die is rolled. Okay, then on the die there are 6 numbers will be there. 1, 2, 3, 4, 5, 6. Then these are all called sample space. That is, if you write these sample space in a set bracket, set of 1, 2, 3, 4, 5, 6. These all 6 are called outcomes. Suppose if you want a desired outcome, that is 6, only one number, set of 6. Getting an even number, you want even number, that is 2, 4, 6, set of 2, 4, 6. The set of collection which has the desired outcomes is called event. If you write the outcomes correctly, then only you will get the correct result. Is it clear to you all, children? Okay, now in this, what is the chance of getting a head when a coin is tossed? 50%? Yes. Now I am giving a chance. When a coin is tossed 100 times, head appeared 85 times, tail appeared 15 times. Now it is 50%? No. Okay, then there are two types of probability are there. One is experimental and the other one is theoretical. Okay, now we will go in a detailed explanation. Suppose two teams, that is A and B, they are playing cricket match. Who will win the match? Okay, without any prediction, team A or team B. Then we can say it is 50% and 50%. Suppose if you take the data, okay, of previous matches, how many matches they played? If team A played 10 and beat 10, then team A won 8 matches. Then who will win? Now, is it team A? No. Is it 50-50%? No. Then team A can chance 80%, whereas team B is 20%. This is called experimental probability. Okay. Now, there is no doubt in between experimental probability and the theoretical probability. Now, we are going to discuss in a detailed way, that is experimental or this probability, that is number of trials in which the event happens by total number of trials will give you the probability of that event. Okay, now we'll take one example, that is if you are going to play Ludo, then what are the sample spaces will come? 1, 2, 3, 4, 5, 6. So number of sample spaces are 6. Suppose by the end of the game, the die was rolled 500 times. What is the probability that the dice was rolled? 4 was on top and the second, the result was an odd number. Okay, The trial rolling a die, number of sample spaces, that is 500 times, n of s is equal to 500. Then what is the event occurred here? Getting as 4. So number of times the 4 is happened, that is 94 by 100, it gives you 0.188. Now second one, that getting odd number. What are the odd numbers in the sample spaces? 1, 3 and 5. So together how many times it is rolled up? 96 plus 70 plus 75. Okay, then getting an odd number is equal to total number of times it is rolled is 241 by 500 is equal to 0.482. Suppose getting a 0. Is it 0 is there on the sample spaces? No. So that is 0 by 500, that is equal to 0. Now if you toss a coin 100 times and number of heads and tails counted, head appeared 47 times, tail appeared 53 times. What is the probability of getting a head and that of a tail? That is, number of times is 100, so probability of getting head is 47 by 100, that is equal to 0.47, and probability of getting a tail is 53 by 100, that is equal to 0.53. Okay, now notice that getting a head plus getting a tail, probability of getting 0.47 plus 0.43, that is equal to 1. So probability of any event is always greater than 0 or equal to 0 but less than or equal to 1. It is calculating the chances of the happening event. Now facts about probability. That is, probability of an event always lies between 0 and 1 inclusive. The sum of the probabilities of all possible outcomes is 1. The probability of an event that is not in the sample space is 0. Okay.